In a troubling turn of events, recent reports highlight a significant shift within the National Institutes of Health (NIH), where a wave of dismissals has disproportionately affected women and minority scientists on crucial science review boards. This sweeping purge raises serious questions about the NIH's commitment to diversity and inclusivity at a time when such values are more critical than ever in the scientific community. The NIH's decision to overhaul its science review boards, which play a vital role in the funding process for scientific research, has sparked outrage among advocates for diversity and equity in science. According to numerous sources, a large number of women and minorities have been let go, prompting allegations of systemic bias within the agency. Critics argue that this move not only undermines the hard-won progress towards inclusivity but also risks stifling innovation by sidelining diverse perspectives that are essential for scientific advancement. Dr. Maria Gonzalez, a former member of one of the affected review boards, expressed her concerns. Diversity isn't just a box to check, it's about bringing different viewpoints that can lead to groundbreaking research. Losing these voices could set us back decades. Her sentiments echo a broader fear among scientists who believe that the NIH's current trajectory could diminish the quality and breadth of scientific inquiry. This controversial action comes on the heels of a broader national conversation regarding the representation of underrepresented groups in science and technology fields. As organizations and institutions grapple with their roles in fostering an inclusive environment, the NIH's approach is being scrutinized as a potential setback. The agency's defenders argue that these changes are intended to streamline operations and enhance efficiency, but the disproportionate impact on marginalized groups suggests a troubling oversight. In a related incident, the atmosphere in schools across the country is also under scrutiny following a stabbing at Aurora Science and Tech Middle School that left one student hospitalized. The incident, reportedly stemming from an argument, underscores the pressing need for improved safety measures in educational environments. Local authorities and school officials are now faced with the challenge of addressing not only the immediate safety concerns but also the underlying social issues that contribute to violence among youth. As these events unfold, the intersection of diversity and scientific enterprise and safety in educational settings remains a focal point for policymakers and community leaders alike. The NIH's upcoming decisions regarding its composition and the responses from educational institutions will likely shape the future landscape of both science and education. Looking ahead, the ramifications of the NIH's recent actions could have far-reaching implications for the scientific community. As pressure mounts for accountability and transparency, it remains to be seen whether the agency will pivot towards a more inclusive approach or continue down its current path, potentially alienating a generation of scientists eager to contribute diverse perspectives. The ongoing dialogue surrounding inclusion in both science and education suggests that these themes will remain at the forefront of public discourse in the months to come. As the world continues to grapple with the repercussions of the COVID-19 pandemic, the promise of messenger RNA mRNA technology has never been clearer. However, recent developments in the United States are raising significant concerns regarding the future of mRNA vaccine research and its potential to transform medicine. Experts warn that a combination of funding cuts and policy shifts could jeopardize the country's leadership in this groundbreaking field. The alarm was sounded by Jeff Coller, a prominent RNA biology expert from Johns Hopkins University, during a media briefing on April 10, 2025. He expressed his fears that the U.S. risks squandering its position in the mRNA space. Coller pointed to a review by the National Institutes of Health (NIH) that has put mRNA vaccine studies under increased scrutiny. He stated NIH-funded researchers across the U.S. are being targeted for projects involving mRNA vaccines, based on what we have seen in other research areas. The next steps could be for the administration to halt funding for projects that are developing these breakthrough mRNA therapeutics. The situation has been exacerbated by significant staff reductions at key regulatory bodies, notably the U.S. Food and Drug Administration (FDA), and the resignation of Peter Marks, the longtime director of the agency's unit overseeing vaccines and biological products.
Coller emphasized the implications of such departures, suggesting they raise serious questions about the U.S.'s future leadership in mRNA technology.
Currently, there are over 700 potential mRNA-based medicines in preclinical development and 267 in clinical trials, with a majority being advanced by US-based companies.
However, the uncertainty surrounding funding has caused apprehension within the industry,
with surveys indicating that nearly 30% of senior life science professionals would consider relocating their operations overseas if support for mRNA technology wanes. Coller noted that almost half of those surveyed have already felt adverse effects from previous policy decisions, including project scope reductions and job losses. Amidst these concerns, the NIH has defended its actions, stating it is realigning research funding with its priorities to enhance the health of Americans. An NIH spokesperson reiterated the agency's commitment to maintaining a standard of evidence-based science while attempting to address the chronic disease epidemic affecting the nation. As the U.S. grapples with these challenges, other nations are seizing the opportunity to invest heavily in mRNA technology. Countries such as China, Australia, and members of the European Union are reportedly ramping up their support for mRNA research, raising fears that the U.S. could fall behind in a critical area of medical innovation. On a hopeful note, Canada is making strides in the application of mRNA technology beyond vaccines. In a significant development, the McGill University Health Centre (MUHC) has reported that the first patient in Canada has received an investigational mRNA-based treatment for bladder cancer. This therapy, which combines mRNA technology with immunotherapy, exemplifies a shift toward personalized medicine. After the surgical removal of the tumor, the patient's unique tumor profile is analyzed to develop a tailored mRNA therapy aimed at training the immune system to target any remaining cancer cells. Dr. Rami Saleh, who leads this trial, emphasized the importance of access to cutting-edge treatments for patients battling cancer, stating every trial is a step forward, not just for science, but for the people we care for every day. The developments in Canada highlight the potential of mRNA technology to revolutionize cancer treatment, providing a glimmer of hope as the U.S. faces uncertainty in its research funding landscape. As the global landscape for mRNA research evolves, it remains to be seen how U.S. policymakers will respond to the mounting concerns from the scientific community. The future of mRNA technology, both in the U.S. and abroad, will likely hinge on the ability to balance funding priorities with the imperative to remain at the forefront of medical innovation. On April 29, the University of Tennessee Health Science Center (UT Health Science Center) will host its 5th annual Giving Day, a 24-hour fundraising campaign designed to galvanize community support for
its mission to improve health outcomes in Tennessee.
This year's initiative promises to be particularly impactful, as an anonymous donor has pledged to match every contribution, effectively doubling the financial support destined for the new Cancer Discovery Fund.
Donations directed specifically towards this fund will be matched twice, tripling the contributions that will bolster vital cancer research.
Chancellor Peter Buckley, MD, emphasized the significance of this year's focus on cancer, highlighting that Tennessee ranks 6th in the nation for cancer mortality rates. This is an opportunity to unify ourselves as a community around something that matters and that is significant so that we can make a dent, Buckley stated, underscoring the urgent need for enhanced research and treatment options. The Cancer Discovery Fund aims to empower researchers at UT Health Science Center who are dedicated to unraveling the complexities of cancer at the molecular level. Their work involves understanding how cancer cells proliferate, mutate, and develop resistance to treatments.
Additionally,
researchers collaborate with clinicians from partner hospitals to translate scientific discoveries into actionable patient care while also providing essential services to those affected by cancer. The importance of this campaign is magnified by the recent achievement of UT Health Science Center in receiving an R1 designation from the Carnegie Classification of Institutions of Higher Education, placing the institution in the upper echelons of research universities.
"We are educating your future nurse, physician, pharmacist, dentist, therapist," said Bridget Grant, Vice Chancellor for Advancement.
Our mission is to invest in the best knowledge, training, and research in order to give every one of our healthcare graduates an experience like no other. This year's Giving Day aims to attract a record-breaking 1,250 donors, building on the previous year's success, in which 1,155 donors contributed $664,850. Beyond the Cancer Discovery Fund, there are additional matching opportunities available for various programs across the institution, including dentistry, graduate health sciences, health professions, medicine, nursing, and pharmacy. Supporters looking to amplify their impact can become Giving Day advocates, receiving personalized links to share with their networks, thus enabling them to track the influence of their outreach. This innovative approach not only fosters community involvement but highlights the collective effort necessary to advance healthcare initiatives in Tennessee. In a parallel development, a significant meta-analysis published in the journal Frontiers in Oncology revealed an overwhelming scientific consensus regarding the therapeutic benefits of medical cannabis in treating cancer-related symptoms. This analysis, which aggregated data from over 10,600 peer-reviewed studies, indicates a robust foundation for re-evaluating cannabis's legal status as a Schedule I substance. Lead author Ryan Castle of the Whole Health Oncology Institute expressed surprise at the magnitude of agreement among researchers, stating, "We expected controversy. What we found was overwhelming scientific consensus." The implications of this analysis are profound, suggesting that cannabis not only alleviates symptoms such as pain and nausea but may also possess direct anti-cancer properties. Researchers noted that for every study demonstrating cannabis's ineffectiveness, there were 3 showing positive results. This 3-to-1 ratio is particularly striking in a field known for rigorous scientific inquiry. As awareness of the potential benefits of medical cannabis grows, the National Cancer Institute estimates that between 20% to 40% of cancer patients currently use cannabis to manage treatment-related side effects. Despite this, questions about accessibility and affordability remain prominent, as the financial burden of cannabis products can limit access for many patients. While these developments unfold, the realm of cancer research is also witnessing a transformation through innovative methodologies. The emergence of 3D cell culture models is revolutionizing research in drug discovery by more accurately mimicking human biological conditions compared to traditional 2D cultures. This shift enhances the predictability of drug responses and reduces the high failure rates associated with clinical trials. Cameron Ferris, co-founder of Inventia Life Science, highlighted the significance of 3D models in studying complex diseases like cancer, stating that they provide a more physiologically relevant environment for understanding therapeutic responses. The use of advanced platforms such as Rastrum Allegro is facilitating the generation of reproducible 3D models, streamlining workflows and ultimately accelerating the pace of scientific discovery. As both initiatives at UT Health Science Center and the broader research community converge on innovative solutions to combat cancer, there is a palpable sense of optimism. The outcomes of the upcoming Giving Day and the findings from recent studies on cannabis will likely shape public health discourse and influence future funding and research directions. As we look ahead, these developments promise to enhance our understanding and treatment of cancer, paving the way for improved patient outcomes and a healthier future. In a pivotal moment for the future of U.S. science and technology, Dario Gil, the nominee for Undersecretary for Science at the Department of Energy (DOE), recently laid out an ambitious vision for advancing critical fields such as artificial intelligence, AI, quantum computing, and fusion energy. During his nomination hearing before the Senate Energy and Natural Resources Committee, Gil emphasized the urgent need for the U.S. to lead in these areas, warning that falling behind could have dire consequences, particularly in the face of growing competition from nations like China. It is time to build a quantum-centric supercomputer. It is time to elevate the capability of AI to advance scientific discovery and do problem solving in ways we couldn't do, Gil stated, underscoring the potential of these technologies to transform research and industry. He predicted that the next 4 to 5 years would herald some of the most significant technological advancements in history, advocating for the mobilization of all available resources to ensure the U.S. does not lag behind its rivals. Current trends indicate that advancements in AI and quantum technology are accelerating rapidly. As Gill mentioned, if we do not succeed on those and we have rival nations like China get ahead of us,
the consequences will be terrible.
His comments reflect a broader trend among policymakers to prioritize investments in STEM education and research. He called for a renewed National Defense Education Act 2.0 aiming to boost U.S. capabilities in science, technology, engineering, and mathematics STEM, a field where he noted the U.S. is currently outpaced by countries like China. Engaging more young people in science is paramount, Gill asserted as he expressed a desire to collaborate with Congress on initiatives that would encourage broader participation in STEM fields. The single most important thing that we should focus on is to engage young people in science, he said, highlighting the need for comprehensive action at local, state, and federal levels. His nomination hearing also raised concerns about the protection of sensitive innovations developed at the DOE's national labs. Committee Chair Mike Lee questioned Gill about safeguarding these advancements from foreign espionage, particularly from China. Drawing on his experience at IBM, where he has been acutely aware of intellectual property theft, Gill promised to work closely with committee members to implement measures that enhance the security of U.S. technological innovations. Gill's appointment comes at a time when the DOE is experiencing a shift in its organizational structure, with the potential for changes in the scope of responsibilities for undersecretaries. His hearing coincided with that of Preston Wells Griffith III, the nominee for Undersecretary of Energy, signaling a new chapter for the department under the incoming administration.
Meanwhile, the intersection of AI and agriculture is also witnessing significant developments.
In a separate initiative, researchers from UC San Diego, UC Davis, and the University of Washington are harnessing AI to revolutionize fish farming, specifically targeting the cultivation of white sturgeon. This project employs advanced machine learning models to analyze images of sturgeon, enabling non-invasive sex determination that promises to enhance efficiency and reduce labor costs in aquaculture. UC President's postdoctoral fellow Edwin Solares, involved in the research, noted the potential for AI to improve sex determination accuracy from an initial 76% to a targeted 90%, which could lead to significant advancements in sturgeon farming practices. The initiative is backed by funding from the USDA and aims to integrate seamlessly into everyday farm operations, thereby setting a new standard for non-invasive fish management. In addition to these agricultural advancements, educational institutions are also adapting to the AI revolution. Stony Brook University's Department of Biomedical Informatics has launched a programming bootcamp designed to equip students with the necessary skills to thrive in data-driven healthcare and research environments. This program, which has attracted a growing number of participants, emphasizes a blend of foundational learning in Python programming alongside practical applications in AI and bioinformatics. As the landscape of technology continues to evolve rapidly, the efforts of leaders like Gill in government and innovative researchers in academia highlight a collective commitment to harnessing the potential of emerging technologies. Both sectors recognize the critical importance of education and collaboration in fostering the next generation of innovators who will drive advancements in science and technology. Looking ahead, the outcomes of these initiatives could shape the future trajectory of U.S. leadership in key technological arenas, impacting everything from national security to sustainable practices in agriculture. In a groundbreaking development for space exploration, British aerospace company Pulsar Fusion has unveiled its ambitious plans to launch the fastest nuclear fusion rocket in history, aptly named Sunbird, set to reach speeds of 500,000 kilometers per hour. This innovative rocket promises to cut the travel time to Mars from the current 7 to 8 months down to just 4. As space travel becomes increasingly feasible for both governmental and private entities, the implications of such advancements are profound, potentially reshaping our approach to interplanetary missions. Elon Musk and Donald Trump have both expressed their intentions to reach Mars in the coming years, and Pulsar Fusion's Sunbird could be a game-changer in this race. The rocket is not only designed to reach Mars quickly but also has the capability to provide a fusion boost to other spacecraft, enhancing their travel efficiency. According to pulsar fusion, the Sunbird will achieve its remarkable velocity without relying on gravitational assists, distinguishing it from traditional propulsion methods. The heart of this groundbreaking rocket lies in its nuclear fusion engine, which utilizes a hot plasma contained within a magnetic field. The company's engineers leverage advanced supercomputing technology to accurately model the behavior of this plasma. Under controlled conditions, the combustion chamber can reach temperatures of hundreds of millions of degrees, enabling the rocket to attain its unprecedented speeds. This innovative design could herald a new era of space travel, with the potential for in-orbit testing of the dual direct fusion engine slated to commence by late 2025 and the engine's operational debut expected by 2027. The implications of such technology extend beyond speed. The introduction of fusion propulsion could revolutionize our approach to space exploration by making it more efficient and less reliant on traditional fuel sources. Pulsar fusion's efforts highlight a significant shift towards sustainable and versatile rocket technology, which could pave the way for more ambitious missions, including crewed missions to Mars and beyond. As we stand on the brink of this new frontier, the excitement surrounding pulsar fusion's Sunbird is palpable. The success of this technology could not only facilitate faster journeys to Mars but also enhance our capability to explore distant planets and moons in our solar system. With ongoing advancements in fusion technology, we may soon see a future where interplanetary travel becomes a reality, sparking a new age of exploration and discovery. As we look ahead, the anticipated developments in nuclear fusion propulsion reflect the potential for a transformative leap in our understanding and engagement with the cosmos. If successful, the Sunbird could redefine the parameters of space travel, inspiring a new generation of explorers and innovators to reach for the stars. In a bold move echoing the policies of former U.S. President Donald Trump, South Korean presidential candidate Hong Joon-pyo has unveiled an ambitious 5-year investment plan aimed at transforming the nation's economy through cutting-edge technologies including blockchain and cryptocurrency. Announced during a recent policy briefing at his campaign headquarters, Hong's plan is set to allocate at least 50 trillion won towards the development of artificial intelligence, quantum science, and atmospheric superconductivity, with a notable emphasis on fostering a robust cryptocurrency sector. Hong, a candidate from the People Power Party, aims to eliminate regulatory barriers similar to those removed by the Trump administration in the United States, stating in order to foster blockchain and virtual assets as a single industry, "I will eliminate regulations." He proposed integrating blockchain technology into public sector services and emphasized the potential of virtual assets to become a significant industry within South Korea. The proposed new industry gate freeze system would allow for the easier entry of new technologies and business ventures without the need for government approval, potentially accelerating innovation and investment in the tech sector. During his presentation, Hong outlined 27 major commitments designed to stimulate economic growth through public-private collaboration, focusing on super gap technologies, job creation, and welfare improvements for the working class. In addition to the focus on technology, Hong's policy package includes a public-private economic revival 5-year plan, which seeks to position the private sector as a leader in economic development supported by government initiatives. He also introduced transformative national projects, such as a sovereign wealth fund project linked to oil development and a goal for a lunar landing by 2030. Tax reforms are another critical component of Hong's strategy, featuring plans to eliminate the comprehensive real estate tax and provide significant tax breaks for inheritance. These measures are intended to stimulate economic activity and enhance the movement within the real estate market. Overall, Hong's comprehensive policy framework serves as a strategic blueprint for establishing South Korea as a leader in innovative free market practices and responsive governance. The implications of such ambitious plans, particularly regarding cryptocurrency and blockchain integration, could position South Korea at the forefront of a rapidly evolving global digital economy. As the election approaches, all eyes will be on how these proposals resonate with the electorate and the potential shifts in policy direction they may herald for the future.